problem that was given to us was a data set where we were given the temperature, ambient pressure, relative humidity, exhaust vacuum, and we have to predict the net hourly electrical energy output. So clearly our features are the temperature, the ambient pressure, relative humidity, and exhaust vacuum. Our target is PE, which is that we want to predict, which is net hourly electrical energy output. Since our output is a continuous numerical value, this is clearly a regression problem, and this is a supervised machine learning problem since we already have the data on which we want to train. We have a target data, and for this the recommended algorithms that I'm using are linear regression, which is a baseline which helps us interpret the problem really well, and the random forest regressor, which basically handles the non-linear relationships much better. The output metrics would be the mean squared error or the R-square value, right? And as far as feature selection and model candidates, we've already selected the features as described earlier, and algorithms, we've already discussed the linear regression and the random forest. Now, as far as the data splitting is concerned, I am using 60%. I'm splitting my data into 3 parts. 60% is a training data, 20% is a validation data, and 20% is a test data. So I will be training my model on 60% of the data, and then I will be validating both the models on the validation set. Once a model has been selected based on the validation data result, I will retrain the model on the training plus validation both data, and then finally I will be using the test data set to give the final output metric. So while using this, there is no data leakage because the test set remains untouched until the final evaluation. A dedicated validation set avoids overfitting during model selection, and the final training would be done on the training and the validation set. So I'm using the 80% of the data for my final training as well. So I've written the code in the Python, and this is the first part of the code wherein I'm splitting the data. My first split is 80-20, wherein 80% is the training plus validation and 20% is the test set. Then I'm splitting that 80% into 60 and 20. 60 by 80, 75%. So I am taking a 25% split here, so which is the training as well as the validation set, right? Once this set is done, then I'm doing the model training and validation. So model training, both the models, the linear regression and random forest, I'm doing the training, and the training is done on the training data. And once the training is done, I'm doing the prediction on the validation data, and I'm calculating the mean square error and the R-square values, right? I'm printing them based on the result here. On the current data, I found the result that random forest is doing a better job in terms of R-square values as well as the mean square error. Mean square error is less, and R-square value, the fit is higher, and hence the final model training is done on a combination of I'm concatenating the training set and as well as the validation set. Once that is done, I'm basically calculating the output metrics, which are the mean square error again and the R-square values. And here are my mean square error. So on the first iteration, I found that random forest is giving a 9.95 R-square, which is higher than 0.92 in a linear regression, and mean square error is also lesser on random forest, and hence the algorithm that wins is a random forest. And based on that, on the test set, I found out the value of R-square to be better, that is 0.96, and error to be even lesser. These test values are a combination of the final model, which is trained on both the test and the validation set, right? And let me also show you the code. This is the code that I have written, right? All these parts are highlighted in my presentation, and when I run my code here, it clearly gives those values as highlighted. And yeah, so that ends my submission.